The last session, what we are discussing? Call by value, call by reference. You have any questions with that? No, no? So you can return any data type and you can send any data type as arguments. Okay. So now we'll continue with the next topic. Life cycle of objects will continue. Okay. We continue with the next topic called as life cycle of object. You see, this object is a very big topic. This object, what you are saying now, is a very big topic. It's not as simple as you're thinking, and it's not as easy as you're thinking also. Okay, but as we go on studying this object, it gives you different meaning in different context. But summary of object is same. What? It's nothing but bringing a code into existence. Summary is same. But one time the discussion will start showing you an object in one different way. Actually, it's something like you're kept on one particular thing on the table and you're viewing it from many dimensions. Okay. Anyway, it's a simple. You can say, like I have got on some particular thing, like say the pen. Okay, but I can mark. I can view this from many dimensions, and in one dimension I can describe this in one way. Okay. Similarly, object also can be viewed from many angles. End of the day, object is nothing but code coming into existence. We know that, but still there's a lot to discuss on this. There's too much to discuss on this. Okay. So to create an object, what we do is we design a class first. Okay. For bringing the code into existence, we design a class first. We put all the code inside the class. Okay, that's encapsulation, and then we create an object. We bring the code into existence. We use it. We know the process. We know how to design a class, and we know how to create an object, how to work with the object. We know all this now. But there's one more important topic what we have to discuss now, called as life cycle of an object. Like when it comes into existence and when it gets destroyed, all that. Okay. So actually this will come into two topics. One is life cycle of an object. Related to this, one more is there called as memory management, and that is called as life cycle of we call it as memory management. Memory management in JVM. So I'll not be discussing about memory management in JVM. This topic will come up to memory management in JVM. Memory management in JVM. Two topics will come up here. One is the memory management and one more is the life cycle of object. So when you are studying life cycle of object, both topics have to be studied, but that topic we'll leave it for later stage. We'll be only discussing about life cycle of an object today. We'll be only discussing this. That we'll see later. And all these things are very essential. All these things are very essential because from a programmer's point of view, if you understand all this, you can code better. You can write your class better. You can work with your objects better also. So all of you know how to write a class. All of you know how to work with objects. Okay. But you can write it still more better if you understand all these topics in a much more better. Okay. So that's what we'll start seeing now. Life cycle of an object. Okay, see, in the world, first I told you Java is picking most of the concepts from real life. Java is picking most of the concepts from real life. Okay, what is there in nature, it is picking those things only. Generally, anything which comes into existence has got 4 life cycle stages. 4 or 5 life cycle stages. Let's see that. First, there are okay, see, it's like this. Anything, see, even we human beings, we also come into existence. We are all objects actually. We come into existence. A mango tree comes into existence. So all these things come into existence. And once we come into existence, what happens? We get destroyed. Okay, so I can just classify our life cycle on 4-5 stages. We'll understand this first. Then you can understand the life cycle of an object, which is very much similar to this. Okay, so let's see this. Generally what happens, see, we come into existence, then we get initialized, then we do service, then we release all our resources, and then we get destroyed. You can see life cycle of anything can be classified into 4 things. Generally I'm telling. Okay. So like see, we come into existence, we get initialized. I'll explain it clearly now. Means we come into existence means we take birth. Okay, then we get initialized. Means we prepare ourselves to work some particular thing. Like we can become a doctor, we can become an engineer, we can become an advocate. So we get initialized. That's called as initialization process. Then we do service. Like continuously what happens is we go on doing, once we get initialized throughout our life, we go on doing the service. Then whatever we accumulate through our service, okay, before we die, what we do? We hand it over to somebody. We release it. We hand it over to somebody and then we get destroyed. Means we die. It's a simple fact. Okay. So same way here, you can take a tree also. Tree comes into existence, it gets initialized. Then every year it will give you fruits, doing service. Okay, tree. Initially it's a plant. Then it grows into a tree. Plant becomes a tree. That is initialization. So first it comes into existence. It takes birth. Then it gets initialized. After getting initialized, what happens? Then it is ready to do service. Every year it might give you fruits. Okay, whatever, depending on the tree. Okay, it might give flowers or fruits or anything. Then before it gets destroyed, it will shed all its leaves. Means it will release all the resources, and finally it will die. Okay, so anything which comes into existence has got these 4 life cycle stages. Anything. Okay, just I am classifying into 4. There might be more. Like if you ask me life cycle of a human being, I can bring more. What? Come into existence, get initialized, then your love affair, all that. Okay, but I don't want to bring all that into things here. Just I am making into a broad classification here. Anything which comes into existence, like marriage, gira story and all, I am not bringing here. Understood? Just we are classified into 5 stages. That's it. Similarly, even our object has got these 5 stages. Okay, but we technically call it as what, coming into existence. We technically in Java we call it as, see in Java. Okay, one more thing. See, coming into existence, how many times it happens? Only once. How many times you take birth? Once, no? Rebirth and all, no, we will not classify now. We take birth only once. Getting initialized. See, you have become an engineer. Again, will you try to become a doctor? After becoming engineer, will you try to become a doctor? After becoming doctor, will you try to become an advocate? No. Initialization also happens only once. In our lifetime, many things happens once. Doing service will happen n number of times. Throughout your life you will do the service, like fruits, every year it gives, flowers, every year the tree gives you. Okay, service will happen n number of times. Throughout our life we will do the service. Then we release all our resources. When will you release all the resources? The timing is very important. You will not release all the resources immediately after you acquire. Before dying you will destroy it. You will release the resources. Just before you die, generally human beings have that tendency, we prepare the will, gill and all that, no. When do you do that? When you are alive and fit and fine, huh? No. Just before you are dying, you will do it. That timing is very important here. Okay. So this also will happen only once, and we get destroyed. Means we die how many times? How many times you die? Only once, no. So you can see here, many things happens only once. But only one thing which happens repeatedly is the service. So Java also follows the same thing. Nothing different. Java also follows the same footsteps. Okay, so what is happening in real life? The same thing happens in Java also. In Java now what happens? Object also has got the same 5 stages. Object also has got the same 5 stages. Okay, in Java, life cycle of object now has got same 5 stages. First one, coming into existence. Technically in Java is called as instantiation. Technically, getting initialized in Java is called as initialization. Okay, initialization technically. Then doing service, okay, we call it as service itself. Then before the object gets destroyed, okay, it has to do some particular things. We'll see what it is. That's the topic what we are discussing today. That is called as finalization. Finalization. Then your object gets destroyed. Destruction will happen. Destruction. So these are the 5 life cycle stages of an object now. Now how is this supported in Java? In Java, instantiation means, how do you do instantiation with help of new keyword? This is how a very brilliant support has been given to this. If at all you want to bring anything into existence, what we do? we use the new keyword. Instance gets created. Then what will happen? Initialization. To support initialization, what has Java given you? Constructor. All of you know this. Then to do service, okay, Java has provided you what? Methods. See what a brilliant support it is giving you. Understood. Now for finalization, let's see what is finalization today. That is the main topic what we are discussing today. Okay. So to understand these three topics, you have taken quite a lot of time. It's not that you understood in one day. Okay, instantiation what it is, initialization what it is, how to use a constructor. Okay, all this you have taken pretty lot of time to understand. This one also will take you some time to understand, but it will happen very fast. Okay, so today we'll be discussing about finalization. Finalization means it's about releasing the resources used by an object. Okay, so we'll be discussing this today. It is the opposite of initialization. Finalization is the opposite of initialization. So finalization. So it is done supported with the help of a method called as finalize method. It is supported with the help of finalize method. Destruction next. Okay, destruction. This will happen implicitly. Destruction will happen implicitly. You don't have to worry about this. In Java, we only bother about allocating memory. We don't bother about destroying memory or reclaiming back the memory. That's one brilliant feature of Java. Very brilliant feature of Java. Okay, in all languages you have to worry about two things. Allocating also you should bother. Destroying also you should bother. But in Java you bother only about allocating, but don't bother about destroying the memory. This is one brilliant feature of Java. So memory management is a big advantage in this particular language. We have seen till now so many powerful features of the language. What are the powerful features you have seen? Portability. Okay, and then type compatibility, robustness. Then OOPS is very powerful. Okay, very rich data types. Control statements are powerful, user friendly. Now you'll see. This is also one more rich feature of the Java language. What is that? Reclaiming back the memory or destroying the unused memory. So this is the topic today. So clearly you'll understand. So this is called as life cycle of an object. One more thing for you to understand, all objects, you can make a note, but now you'll not understand this. Okay, but within 2-3 days I'll be talking more about this, then you'll understand. In JVM there are two types of memory. One is stack and other one is heap, which I'll be starting, the topic I'll start after 1 or 2 days. Just wait. Okay, so in that is what is memory management. So we'll be seeing that very shortly. Okay, all objects are created in something called as heap memory. Okay, there are two memory in Java. Memory in Java, broadly we classify it into, memory in JVM rather, is classified into two types, stack and heap. So all objects reside in heap. All objects reside or live in heap. Reside in heap. So note, all objects reside in heap. I am just taking you to the memory level. Very shortly we'll be reaching there. Okay. So all objects reside or live in heap. So we'll be going to that point now. Now let me explain you with some code itself. Okay, here also see, instantiation of an object happens only once. See the same support. Initialization happens only once. Service means constructor, how many times it will execute? Only once. When a new object gets, you can create n number of objects, that is secondary, but one object is created how many times? Only once. So you can create multiple objects of one class, but one object is created only once. Initialization means in one object, how many times the initialization will happen? Only once. Constructor is used for doing initialization. So in one object, constructor gets executed only once. Afterwards you cannot call the constructor in that particular object. You can allocate new memory and call constructor in other objects, but in one object you can't call the constructor again. Understood? Once it completes execution, over. Constructor cannot be executed in that particular object at any point of time or at any cost. You cannot execute it. So constructor also only once. Service, methods you can call n number of times now. Methods you can call n number of times. There is no limit to this. So after you create the object, 1000 times you want to call the method. See, box B is equal to new box. This is how you create the object. box B. B is equal to new box of 1, 2, 3. So here in that particular memory location the constructor gets executed. After the constructor is executed, now see, I cannot call the constructor again, but method I can call 100 times. B dot volume, B dot volume, B dot volume. We can call the method 100 times, no issue. There is no limit for calling the method. So this is only nothing but called as service. So service, how many times you want, you can go on executing. So you have to decide very carefully which code you'll write where. So when you write a class, all these things become very important. So we still continue to discuss how to write a class. We still continue to discuss how to write a class, because the more clearly you write a class, your objects behave in that way. So objects always behave in the way you write your class. Understood? Objects always behave. Remember this. So class is a template for an object, or object is an instance of the class. So how you write your class, objects behave in that way. Understood? So we are still learning how to write a class. We have seen a class can contain what? Instance variables. It can contain what? Constructors. It can contain methods. Today I'll add one more member to it, and that's called as finalize method. I'll be adding one more member called as finalize method, and we'll see why we add that member today. There should be a technical reason. No, simply go on adding members is not the solution. Why we technically add that member is the prime question here. So we'll be talking about a method called as finalize. This method I'll be talking today, that itself is called as finalization. We'll be seeing it. So methods can be called 100 times. Okay. So then this also, okay, now before the object is destroyed, it has to release something. That also happens only once. And finally object gets destroyed. That will also happen only once. Same, ditto to ditto. Life cycle of human being and life cycle of an object, no difference, because everything in the world is object. Everything is encapsulated. We are also a complex thing. We are also encapsulated. Many complex things are inside us. Understood? Similarly, in your object also many complex things are there inside it. So if you want to work with the complexity of the object, you will be using what? Reference variable. Understood? If you want to work with the complexity of any object, what do you need? A reference variable is needed to work with the complexity of any object. Without the reference variable, can you work with the complexity? No, it is impossible to work with the complexity without the reference variable. Are you clear with this? Okay, so till now you have seen object in a different way, but now things will start seeing in a different way. But subject is very clear. Object is nothing but code coming into X. Do not forget that basic information. Okay, if you forget that, it will become difficult. Okay, object is nothing but bringing code into existence. Okay, fine. So keeping this in mind, I'll design one class now. Okay, keeping this in mind, we'll see how to design one particular class. Long back, I had explained you how to write how to use a constructor. Do you remember that? How to use a constructor, how to use methods, I had explained to you. Okay, let's revisit that topic again. I told, like supposingly there is a scenario. Supposingly there is one scenario, I want to read from a file. I want to update a file. Like this you want to use resources. Till now we have not used powerful resources. We have not written any such code. Our code is not very powerful till now. Okay, we are writing very simple classes like class, box and all that. Later on when we write our code, it becomes more powerful. Okay, so we'll start working with resources and all. But when you work with resources, let's see how you handle and manage your resources now. What happens? See, this will be a scenario. I'll give you a scenario now. The scenario would be, I'll take this one. Shall I take this space now? Are you getting it now? It's highly related. This and this are highly related. Understood? Okay, let's take the scenario like this. 1 second. See, there's one file now. It is abc.txt file. Some file is there. Now I might want to write something into a file like hello, how are you? Okay, I might want to write something to a file, or I might want to change, means this is writing. Okay, then I might want to add one more line to it, welcome. So that time what means, one is you want to write something to a file. That is one operation. Right, the one operation what we want to do now is write to a file. Something newly you want to write. Second is you might want to update. Updating means what? Hello, how are you is there. Okay, I want to put on hello, I want to do this thing now. Question mark and comma I have to put. hello how are you is there, but I want to put some comma and question mark. This is updating. Means making changes to existing thing is called as updating. Writing to a file means what? Writing completely new thing. Okay, but modifying something is called as what? Updating. Okay, I want to update a file. Or I might want to delete the contents of the file. Delete the contents, not the file. Delete the contents of a file. Or I might want to read the file. These are the 4 operations I want to do now. Now all this logic, can you write in main method? If you write in main method, what will happen? You can't reuse. Getting the idea now? I'll write now, see this. Class demo, public static void main, all this logic. See, first I'll write the code to write to a file, then I'll write the code to update a file, then I'll write the code to delete the contents of the file. This is first doing the first thing, this is doing the second thing, that's doing the fourth thing, then I write the code to read the file. But when I run the main program, what will happen? All the code will execute. No. This is not what I want. What will happen is I don't want all the code to execute at once. Okay, sometimes, see, there are some problems here. When you write all this, one is you can't reuse. Supposingly here you have written the code to write to a file. Again, if I want to write to the file later stage, again I have to write the same code. I can't reuse. Second thing is, when you run the code, all the things will execute. This will not be the scenario. Sometimes one thing you want to do at one time. It's not that always you want to do all the 4 things. So to reuse it properly, we generally start doing, what we do is we write it in methods. So if you write it in methods, what logic you want to use when, that time you'll call the method. That's a better option. Understood? Instead of writing it all over like this, okay, one is reusability. If you write it in a method, it's reusable. And second thing is, whenever you want, you can use it. It's not like it will execute in a sequential manner now. See, supposing if I had written in some methods like M1, M2, M3. Okay, if I had written it in methods somewhere outside, what will I do now? If I want to read the file, I'll call M1 method. If I want to update a file, I'll call M2 method. Otherwise, I'll just remove this. So now managing things becomes easier if you write it in methods. So that is why always any logic we write, we prefer to write it in methods only. That's a basic idea. Any logic we write, we prefer to write it in methods only. But now where do you write the methods? Will you write the methods in the class which contains the main method? No. Obviously we write all these methods in another class. Okay, we'll not write all the methods in the class which contains the main method. We can write all the means, we can write multiple methods like this, and all these methods we can keep it in the class which contains the main method. But managing this class becomes a headache now, because this class starts growing and too much lengthy it becomes. Like say all the logics, you'll write it in one method and start putting the method in a class containing main method. How many methods will be there in your class now? So it becomes very tedious. So that is the reason what we do. We start organizing things now, separating. Like the code related to handling a file, I'll keep it in one class. The code related to calculating interest, simple interest or I'll keep it in another class. The code related to doing arithmetic operations, I'll keep it in another class. That's how we go on organizing. Are you clear with this? So now definitely we are going to write methods now. So let's see now. Now we have decided. Are you clear now why we are going for another class? We found out all the things now. Okay, one is writing all the code in main method. Second one is writing methods in the class containing main method. That's also ruled out. So now we have decided finally to write the code in a separate class. So now let's start seeing now how do you write this code in a separate class very efficiently. Writing code, getting output is easy, but how to write it very efficiently and handling and managing all this resource is very, very important now. So what we'll do now, see, this is how we actually write the code now. So see this, class, hello. Okay, I'll have one constructor here. We'll see how you use the constructor now, how to use method also, how do you use finalize also. All the 3 things we'll see now. So we have a constructor right now. Okay, then I'll have one method like write to a file. This is a method name. Instead of giving it as M1, M2, M3, we give good method names like this. Okay, a write to file. So what will happen now? So you have to write the logic here. Or 1 second, I'll go with your names only because you are not used to such good names because you are still addicted to what? M1, M2, M3 only. So in M1 I'll write the code to write to a file. Means you'll write the code to write to a file. Correct? In M2 what you have to do now? Write code to update a file. Like this you have to go on writing 4 methods now. Fine. So now see, this is a client code now. The client code would be this. Class demo, public static void main. Okay, see now. Hello, h is equal to new hello. I'll create the object. But h dot m1 means it has to write to a file. Yes or no? So this is the file now. See, this is the file abc.txt. So one object gets created, this code has to write to this file. Very simple. But to write to this file, you need the connection to the file now. Without getting a connection to the file, how do you do the input output operation? So to write to a file, you have to write some code here. What is the code you have to write? First, you have to write, first step, you have to write code to, write code to connect to file. Then you'll write to, one second. Write code to connect to file. Then you'll write to a file. Write contents to a file. Then you'll close the file. Close the connection to file. Yes or no? Or instead of write code, we'll write open connection to file. It will be very simple. Open connection to. So you have to open the connection to file, then write contents to the file, then close connection to that file. Similarly for update also what you have to do? We had discussed this problem long back. Understood? What you have to do? You have to open connection again. Then you have to write or update the file. Then you have to close the connection to file. Understood? Similarly M3 method I'll write. In M3 method also what will you do now? Open connection to file like this. In every method you have to write one common code now. Open connection to file and only one will change. What is the thing which will change now? Third one is delete the contents of the file. And lastly you will close the connection. See every method you see now. Close the connection to file. Now see there's a problem. Similarly you'll write for what? Read from the file. One more method M4. Same thing you'll be doing now. Now this becomes a headache. Because here, now when I create the object, one object gets created which will have M1, M2. See these are the methods in your object now. You have an M1 method, you have an M2 method, you have an M3 method, and you have an M4 method. See this is your object, this is H. So now what happens, when I call h.m1, what will your object do now? It will connect to the file, it will write to the file, and it will close the connection to file. Similarly if I call h.m2, again it will open the connection to file, again it will update the file, again it will close the connection to file. Similarly if I call M3, same thing will happen. But see now, methods can be called any number of times, remember that? So every time I call M1 method, I will call only one method 100 times. Or you might call a different method, that story is different. But every time you call a method, what's happening now? The connection is getting established. So simply you're burdening the network. You're burdening the network. You can get the connection only once. Use the connection once. Okay. And you can close the connection also only once. Unnecessarily for every method call, why do you want to get the connection, close the connection? This is, one is you are doing redundant coding. Second thing is you are not managing your resource also properly. One is the redundancy in coding. Redundancy means what? Duplicacy in coding. Again and again, again and again you have to keep on coding. This is a big headache. Okay, so second thing is managing the resource also is a big headache now. You are not managing it properly. You'll get the output. I'm not saying if you write the code like this, you'll not get the output. Definitely you'll get the output. But problem is you are not written your code efficiently. So to solve this problem, what is Java doing now? It is giving you two powerful things. One, it gives you a constructor. So constructor is used for what? Initializing the object level resources. See, generally people tell our construct is used for initializing instance variables. I do agree, I'm not saying no. Okay, but your instance variables will not be as simple like WHND. Your instance variables will be very powerful resources like file connection, database connection, socket connection, anything like that. Understood? See, this is one file now. So here we'll be having a resource as something called as file input stream or something like this. We'll have one very powerful resource like this. FIS. If it is a database, we'll have one variable of type connection con. See, this will be for file. This will for database. So like this, our instance variables will be very powerful. Understood? We'll be seeing it very shortly. Our instance variables will not be as simple as WHND. They'll be very powerful instance variables. Okay, and these variables will be initialized with resources. So constructor is basically used for initializing what? Instance variables, agree. I'll agree to your words. But basically our instance variables will be of type resources. So that's why we always say constructor is always used for initializing object level resources. Now what do you mean by an object level resource? A resource which is required in two or more methods. Two or more methods. Okay, see, this method also needs the same resource, the second method also needs the same resource, the third method also needs the same resource. So that is when we term that resource as a object level resource. Understood? That is when we term it as object level resource. A resource which is required in two or more methods is called as object level resource. So constructor is basically used for initializing object level resources. Okay, so now that is why what we do, opening the connection, we'll do it here now. Where? Not here. Or 1 second, we remove it from here and bring it, shift it to what now? Okay, we open connection to file here. Here we'll open the connection to file, or you can open connection to database. But technically it is called as what? Initializing. See, why do you use a constructor? Initializing object level resources. Understood? Now the methods, what do they do is they use object level resources. Remember that. They'll use it. Okay, now one more thing, you should be very clear with this. Now it's not that always database connection and file connection will be made as object level resource only. Supposingly if the connection is required in only one method of your class, we make it as what? Local resource. We write the code like this only. Understood? If the connection is required in only one method and we want to use the connection only in one method, so we make it as, write the code like this only. Open connection and close, use the connection and close the connection here. Okay, so this is very important for you to understand now. Sometimes what happens, you don't want the resource to be used in multiple methods. It might be file connection only. So if I ask you whether you'll make the file connection as object level resource or method level resource. Okay, you should not tell object level resource always. It depends on the scenario. Okay, file connection also will be made as what? Sometimes local resource. Sometimes it will be made as object level resource. So when will you make file connection as a local resource? When it is required in a single method. But the same file connection, when will you make it as object level resource? When the resource is required in multiple methods. Or database connection also. If it is required in one method, method level resource. If it is required in multiple methods, object level resource. Socket connections. Okay, only one method, local resource. Many methods, object level resource. Like this it will happen. So methods, what they do is they use object level resource. See this, one thing I'll tell you very clearly now. Okay, I'm finding insufficient space to write here. Okay, see, it will initialize, methods what they do is initialize local resource also and use both what? It will use both method level and object level. See, this is how you have to write the code. Remember that. You have to use both the resource and object level resource. And in methods what we do now is, okay, write contents to file. Okay, initialize local resource, use both method level and object level resource. Then after using, you will close only what? Method level resource. See, any resource you open should be closed. Remember that. Any resource you open should be closed, whether it is local or object level. But method level resource, you will close it here only. Why? It should not be open, because if you leave it open, who will close it now? Understood? So you will always definitely close it here. But you will never close object level resource here. That's one thing you have to understand. You will never close the object level resource, because if I write the code here to close object level resource, what will happen? It cannot be used by other methods. See, by chance, I'll close off the file connection here. See now, see the code now. See the client code. I'll write hello, h is equal to new hello. So I'll get the connection to the file. I'll call h.m1. M1 method will write to the file. After writing to the file, it will close the connection to the file now. If I call M2 method, what will happen? M2 method cannot use the file connection. So you should never close the object level resource. Now one example I tell you here. See, here you can consider which one? File connection as object level. Okay, and you can consider database as local resource. You can consider, but don't think database should always be what? Local resource. Just I am telling you an example. Now database, see, I want to read from the file and write it to the database. Example. I want to read from the file and write it to database or something like that if I want to do. So file connection is required in all the methods. But I want to write something to the database. So that time I will make database as local resource, because it is required in only one method. Are you following now? Okay. But do not close the object level resource here. This is wrong. You should not do this. You should only close what? Method level resource. This is wrong. You should not do this. Understood? So you need a replace now. See, h.m1. Again, what happens now? You got the, see, when I created the object, you got the connection to the file. When I call h.m1, what happens? It is using the resource, which one? Object level also it will use, plus local resource also it will use. But it will close both the resources. Now M2 if I call, or same method if I call again h.m1, it cannot use what? The object level resource. I call the same method or call a different method. You cannot use the resource again. Which one? Object level. Method level, yes, again it will initialize, again it can use, not a problem. Okay, but object level resource you can't use. So this becomes a headache. That is why we should never close the object level resource here. That's one problem. You should never close it. Okay, similarly what happens? See now. I'll write code here also. See in M2 method, what we do now? Here, see, I don't need any local resource. So I might only use what? It's not that all methods will have local resource. Understand now? Some methods might have local resource, some methods might not have local resource. They might, but they'll be using the object level resource. Use object level resource. Same way M3 now. What it will do? It will not open the connection, because already connection is open. It will only go on using the resource. See, it will only use it. See here, use object level resource means what is it? It will update the file. That's it. Here also, what it will do? Use object level resource. M3 method, what it will do? It will delete the contents from the file. So this operation it will do. So here it will be writing to a file. Get it now? So M1 method will write to file. This will update the file. This will delete the contents of the file. M4 what it will do? It will use object level resource and it will read the file. Fine. Everything is perfect. Everything is perfect. But when will the object means, see now, one more thing we have discussed till now. You understood all these 4 operations now? Okay. So now when you go on creating the object, see h is equal to new hello, all this will be happening now, h.m1, h.m2, you can go on calling the methods. But suddenly, see in Java, there is possibility for you to only allocate memory. In Java, you cannot destroy the memory. That's one big thing in Java now. You cannot destroy. In C language, what you do? You allocate the memory by telling malloc. Okay, or you can say malloc, or one more is there, calloc. Something like that you'll say, and you'll allocate the memory. In C++, just I'm taking examples. In all languages you have this headache. You have to allocate memory using new, and you have to destroy the memory using delete operator. So in every language, in most of the languages, you have to bother about two things. One is allocating memory also, other one is destroying the memory also. Because if you don't destroy your memory or deallocate the memory, simply your memory will become full now and your application will crash. So memory management is also one big headache. One is memory management. Second one is resource management. So managing these two is a very big headache. One is, we have to manage two things now. One is what? Two. When you write code, you have to manage two things. One is memory management. Second one is resource management. So we'll see first how to manage the resource. We'll do, means we have got two management to be done here. So right now I'm teaching you how to do resource management. Then I'll be teaching you how to do memory management. Management, when you write a program, is of two types: memory and resource. So right now we are seeing how to manage our resource efficiently. Okay, but now say, fine, how do you destroy the object in Java now? There's no way. We can only allocate memory. If you say new, memory will be allocated. But how do you destroy it? There's no way to destroy it. If you want to destroy it, only one thing you can do. You can dereference it. That's all you can do. If you don't want to use an object, you have to abandon it. Abandon it means leave it. That's it. If you leave it, automatically it is eligible for something called as garbage collection. Okay. Automatically there is something called as a garbage collector here. That will come now and it will clear the destroyed, which one? Dereferenced object. It will destroy the dereferenced object. Are you clear with this? So we don't bother. If you want to use the object, see, as long as you want to go on using the object. But if you want to destroy the object, just dereference it. Now what are the ways you can dereference an object? Many ways are there. Hello h is equal to new hello. See this. I'll be writing a program on this very shortly. So one object gets created. Hello h2 is equal to new hello. So one more object gets created. Hello h3 is equal to new hello. So one more object gets created. So I created three objects. I can use the objects here, h1.m1, h1.m1. I can call the same method in m1 many times. That is doing nothing but service. But suddenly if I say h1 is equal to null, one dereferenced object gets created. h2 is equal to h3. Means here, first h1 got created. Then h2 got created. Then h3 gets created. Three objects I created. Then what did I do? h1 is equal to null. Now h1 refers to null. So this is dereferenced. Now what did I do? ht is equal to h3. The value of h3 I gave it to h2. Now h2 will refer to what? h3. So this is dereferenced. So these are the two dereferenced objects now. Understood? See, the address might be 150 here. For this might be 250. This might be 350. So what did I do now? h1 is equal to null. So I gave the value of null to h1. So it is dereferenced. Can I work with this object now? No variable is referring to this object. One more thing now. h2 is equal to h3. What happens? Now h2 will get the value of h3. What is the value of h3? 350. That 350 value is given to h2 now. So what happens? It is again dereferenced. Which is dereferenced? h2. h2 will now refer to this. Now there are three variables, h1, h2, h3. Three variables are there. But h2 and h3 are referring to this particular object. h1 is not referring to any object. h1 is not referring to any object, but h2 and h3 are referring to this particular object. Now there are two dereferenced objects now. So in Java you don't have to bother about what? Destroying this memory now. Like this, there are still more ways how a dereferenced object gets created. Still more ways are there. I'll be showing you what are all the different ways an object gets dereferenced. I'll be showing you. But once it is dereferenced, you don't have to bother about this. Leave it off. Okay. Automatically what happens? There is something called as a garbage collector. Now, what is garbage collector? It's on program now. In the JVM, it's on program. So the JVM will execute the garbage collector, or we generally say it sends the garbage collector. The garbage collector will come and reclaim back the unused memory. So in other languages, before you do this, what you have to do? You can't do this. Okay, means you have to take care to allocate also, you have to deallocate also. Both you have to do. Okay. So this is how it works in other languages. But in Java, we don't bother about destroying the memory. It will be destroyed automatically. Clear? So all you have to do is abandon the object. Abandon means dereference it. Understood? That's all. It will be automatically. So that's one beautiful thing what we have got in Java. Okay. So see here you might ask me, why should I allocate memory and say h1 is equal to null, h2 is equal to h3? You might have questions. Generally dereferencing of objects will not happen like that. Dereferencing of objects will happen in methods that I'll be showing you very clearly. See, like example. See, there is one class called as A. Now in A class I'm having one method called as fun. So I'll say simply box B is equal to new box 1 2 3. So I've said new. So what has happened? As soon as the method A is equal to new A, I'll write the code A dot fun, I'll call. So what happens now? Box object gets created. But as soon as this method completes execution, local variables are destroyed now. So when local variable is destroyed, who will refer to that object now? So like this, the dereferenced objects go on getting created. There are many ways how a dereferenced object gets created. One, when the variable goes out of scope, when your reference variable goes out of scope. Going out of scope, you know, no? Goes out of scope and is destroyed. You know, there are two things. Variable out of scope but is alive. Variable out of scope and destroyed, dead. When the variable goes out of scope and is dead, so that time the object becomes dereferenced. This is the main thing. But I'm just explaining in this scenario here. Okay, if an object, see, the actual way of dereferencing happens in that way. We never go on deliberately saying h1 is equal to null and all that. Just first I'll introduce like this, then we'll go to that level. Okay, so somehow the objects get dereferenced now. Once they are dereferenced, you don't have to bother about it now. Automatically garbage collector will come and collect that dereferenced object. But they have designed the garbage collector in one more way. Before it collects the dereferenced object, in all the dereferenced objects, what it will do is, it will execute one method called as finalize method. They have designed it like that. They have designed one method. Okay, so if you want, you can use that method now. I'm introducing this method now. See this. So you know how to use a constructor, you know how to use a method. Now we are learning how to use what? One method called as finalize. Okay, so it is in this finalize method, you have to write the method like this only. Public void finalize. Spelling, be careful, not SC, ZE. The same name you have to use. Like how a constructor should have the same name as class name, finalize should be like this only. So see, among the two resource management, okay, among the two management, resource management and memory management we don't bother in Java. Yes or no? Memory management is not our headache in Java. We have to only bother about what now? Resource management. We don't have to bother about memory management. Only, see, you have to bother, if you want memory, allocate. If you want memory, allocate. How much memory you want to go on allocating, new, it will allocate. But do not bother about destroying memory in Java. That's the best part what you got in Java now. How much of memory you want, go on allocating, new. Like A is equal to new A, fine. B is equal to new B, fine. Box B is equal to new box, fine. Test T is equal to new test, fine. Hello H is equal to new hello. Go on allocating. But do not bother about destroying the memory. So memory management is taken care implicitly in Java. Only we have to bother about what? Resource management now. So how we do resource management, we'll see now. So what happens in the finalize method, we write code to release what? Object level. Alright, I'll do one thing. I'll remove M4 and write it neatly. Okay. Assume that M4 is there. Because I'm not having space, I'm removing it. Public void finalize. So what will you do here? Close object level resource. Means here what will you do? You'll write code to close connection to file. That's it. So now the garbage collector comes to collect these dereferenced objects. In these objects, what are the method you created? You have M1, right? You have M1 method, you have M2 method, you have M3 method, as well as you have finalize method. Yes or no? So you have created how many hello objects? M1, M2, M3, M4, as well as you will have. See, when you created objects H1, H2, H3, what has happened? As your class, same code has come into existence. M1 is there, M2 is there, M3 is there, M4 is there, finalize is there. Similarly, you have M1, M2, M3, M4, and you'll have finalize. So when the garbage collector comes to collect the dereferenced object, first what it will do now, it checks, is there a finalize method in your object? First it will be checking. If it is there, first it will execute that. Before it collects the dereferenced object, what it is doing? We know it will be collecting. Memory will be reclaimed back. Memory will be reclaimed back. But before reclaiming the memory, what it will do? It will check is there a finalize method. So if you return it, it will execute. Okay, and when will you write this? When we want to release object level resource. Understood? Simply do not write it. Okay, so simply do not write it. When you want to release object level resources, that's when we use this. So basically we are using finalize method for what? Finalization process. Yes or no? Before the object gets destroyed, what you want to do? Write that code here. Before your object gets destroyed, what you want to do? That code has to be written here. Like how you write the initialization code in the constructor, here you have to write the finalization code. Okay, in all the languages you have two headache. One, you have to write finalization code also. Second, you have to clear the memory also. Two things you have. In all the languages you have two headache. One is what? Finalization process. Means before the object gets destroyed, what it should do. And second thing is you have to take care of memory management also. But Java says do not bother about memory management. You only bother about resource management. And that resource you clear it in the finalize method. Rest all we will take care. So it's one standard method now. Finalize is one standard method which is used by the developer in every class to release object level resource. Okay, and when garbage collector comes, carefully notice you are having M1, M2, M3, M4 method in all the object. Garbage collector will not call M1, M2, M3 method. It has been designed to call only finalize method. Garbage collector has been designed, even though your object is having other methods, M1, M2, fun, show, test, anything it can have. Garbage collector will never call all that. So finalize is the standard method now. So if you want to write object release code, means object level resource code, means if you want to release object level resource code, that code you write it in finalize. Because if you write it in any other method, custom methods we say, like M1, M2 and all that, it becomes your headache to call that method. So we don't bother to call now because we are writing it in. If you write it in other methods, who has to release the resource now? Developer has to release it. How? You have to call the method because garbage collector is not going to call which method? M1, M2. Supposingly I write the resource release code in M2 method now. Supposingly I write. Okay, and I'll say H1 is equal to null. Now what will happen? Nobody can, means the garbage collector will call finalize, but if there is no code in finalize, what will happen? The resource will not be released now. So before you dereference, it becomes your headache to call that method. That becomes one big headache. That's why they are telling it in a standard way. You don't write the resource release code in any method of your own. Or the finalization code, simple. Let me put it like this. The finalization code, do not write it in any place you want. Just write the finalization code in finalize method only. Finalization code is nothing but some resource release code. Finalization code is nothing but resource release code. Initialization code is nothing but resource initialization code. It's the dead opposite. See how you use constructor, use finalize in that way, as simple as this. How you use finalize now? In the same way, we use the constructor for initialization and we use this for finalization. Difference between initialization and finalization is used for initializing the resource, finalization is used for releasing the resource. Neatly designed. And if you write it in some other method, what happens? Resource will not be released. And if your resource is not released, remember this one loophole, your object is not eligible for garbage collection. If your resource is not released, your object is not eligible for garbage collection. Supposingly you got the connection, see here you got file input stream. File input stream is there now. So this is the variable which will be getting the connection to file now. File input stream has got the connection to which one now? File. You got an instance variable, notice. File input stream or connection. Okay, that is here now. File input stream or connection will be there. So now this has got connected. And if you dereference this object also by telling h is equal to null, this object is not eligible for garbage collection because this object is having some resource. Understood? So it will keep moving in the JVM itself. Understood? It will keep moving in the JVM itself. So it is mandatory to release the resource before the object is destroyed. If the object is not releasing the resource, it is not eligible for garbage collection. Understood? Now it will become like on Betal there. In the JM only it will be moving. You know the life cycle of human being, no? Same thing. See, we take birth, we get initialized, we do service. Now without completing your last, which one? They ask now, last wishes. If you die, what will happen? You will not be released. You will become on Betal. Yes or no? Without completing the last wishes. See, before we die, generally they ask, what are your last wishes? Why they ask that? So that we are freed from this world. Understood? Same way here also. To release it from the, which one? From the memory, we have to release all the resources. The timing is very important, and JM is very important. JM is very intelligent enough to call the finalize method only on what? Dereferenced objects. It will not call on all the objects. It will never call the finalize method on referenced objects. So as long as the objects are referenced, it will not call the finalize method. Understood? Are you clear with this process now? So I'll put it into coding and show you. Okay, one more thing. Can I call finalize method h dot finalize? Can I call it? Yes, we can call. It's a normal method now. But calling finalize method will only what? Release the resource, but it will not destroy the object. And that object becomes what? Useless object. Supposingly I call h dot finalize. It will execute, finalize will execute. After finalize execute, still it is referred now. I'll call h1 dot finalize. Still it is referred now. Once finalize is completed, it's still referred. I can call h1 dot m1, but how will m1 method execute? You have closed the connection. You cannot use m1 method, you cannot use m2 method. So the object becomes useless. So calling finalize explicitly by the developer will only release the resource, but will not destroy the object. Understood? So we should not call it. You can call it explicitly, but it will only release the resource, but will not destroy the object. Is still referred. See here h1 dot m1. See, I'll call hello h1 is equal to new hello h1 dot m1. I'll call it. But after calling, I'll say h1 dot finalize. I can call it. Once I call h1 dot finalize, what happens? Finalize method completes execution. Resource is closed now. Now how will I call m1 method? Resource is closed. I cannot use the resource. So calling finalize method explicitly by the developer will only close the resources, but will not destroy the object, or it will not dereference the object also. Understood? So the only way you can destroy an object in Java is by dereferencing it. The only way you can destroy an object in Java is by dereferencing it or abandoning it. Abandoning means just derefer. That's it. And what are the different ways an object gets dereferenced? I told you. h2 is equal to h3. I'll show you now. I'll just clearly write a program and show you all this. Clear this? So why will you use finalize now? For releasing object level resources. That's it. Nothing else. So when you write your code, you should keep all these things in mind and write. Like, okay, I want to write some code. Just now I explained you. Our requirement was what? I want to read a file, I want to update a file, I want to delete the contents. So that was the requirement. So and this is your requirement. Now how should you think? Can I write all this code in the class, in the main method? No, because we can't reuse. Now I'll write it in methods. Can I write these methods in the same class containing main method? No. So we write it in another class. So when you are going to write this code in another class, now you have to split. How many methods? Okay, 4 methods are required. One for reading to a file, one for writing to a file. You'll understand now. So you have to write 4 methods. So when you are writing 4 methods now, what will happen now? You need the resource in 4 methods. So obviously it becomes object level resource. So that object level resource you do it in the constructor. Okay, and that object level, same object level resource, where will you do? What will you do now? Where will you release it? In finalize method. As simple as this. So this is how you write classes. Understood? Till now I have shown you how to write constructor. Till now I have shown you how to write methods. But today I am talking about how to write finalize method. So why didn't I show you till now finalize method? You might have a question. We were not using powerful resources like this. We are using variables like WHND, class box, WHND I was using. But later on when we start using powerful instance variables like file connection, database connection, this code will follow. Understood? So they have designed everything technically so correct that it becomes easy for the developer to learn and understand here. So you should know when to use a constructor, when to use a method, and when to use finalize method. So you can see the life cycle now. The object instantiation, how many times it happens? Once. Initialization in one object happens only once. Service n number of times. You can call the method n number of times. Finalization happens how many times? Only once. When it happens? Only on destruction implicitly. Developer is not going to destroy anything. Okay, so developer has the ability to only create objects here, but not to destroy objects here. Are you clear with this? Isn't it neat and elegant, clean? So Java, we bother only about resource management. Remember that. We do not bother about memory management. This we do not bother. We bother only about this because memory is reclaimed back by JVM itself or garbage collector. Now, what is garbage collector? It's one program which is running in the JVM. Understood? So it will come now. Whenever it wants, it come. Now we'll talk about garbage collector. Life cycle of garbage collector is another story. When will it come? When will it not come? That and all we'll see. Okay. Generally, the garbage collector will come when there are too many dereferenced objects in the heap. Generally, and it can come anytime. We don't know. It will come implicitly. It will come like implicitly. Okay. Whenever it wants, it will come. So supposing I have written around 1000 lines of code, it can come in the second line. It can come in the fifth line. It can come in the 100th line. There is no timing for it. But whenever it feels like, generally when it will come is when there are too many dereferenced objects in the heap. That time it will come. Generally, it can identify that. Okay, the garbage collector itself means the JVM itself will send the garbage collector. Once it comes, it will reclaim back all the dereferenced objects. But before reclaiming back all the dereferenced objects, it will first call finalize on that, and then it will reclaim the memory. Okay, are you clear with this? And if your object is not releasing the resource, it is not eligible for garbage collection. Remember that. It is called as memory leakage. Understood? It will never be. It's never eligible because it's initialized with some resource. So such kind of resource, such kind of objects are not eligible for garbage collection. You know tsunami, no? Is there any timing for tsunami to come? No. Same way garbage collector. When it will come, we don't know. But it will come now. Okay, if you want, you can call it explicitly also. Okay, there's one way, I'll show you now. I'll code and show you. You can call it. But still when I call it, there's no guarantee it will come immediately. It will come sometime. Okay, later or somewhere. That process I'll explain you later. Just concentrate on life cycle of object. That is my discussion now. Not garbage collector memory management. My real topic today is life cycle of an object. So you focus more on this. If you have any questions related to life cycle of an object, you can ask. Okay, about how garbage collector comes, all that and all that I'll be telling you in the next. I told you memory management. That is another subject. So that I'll be explaining you later. Okay, first if you understand all this, that we can understand very clearly. Are you clear with this process now? So I'll write on program to make you clearly understand this. Okay, and you can see like methods can be called n number of times. All that I'll write and show you now. Shall I clear everything what I've written now? I'll show you now. Objects getting dereferenced, all that I'll show you now. Shall I clear everything? So understood this process also now. Instantiation once, initialization once, service n number of times, finalization. I removed it. Service, initialization, instantiation. Are you clear with all this? So your object in Java has got how many life cycle stages? 5. Same human beings have life cycle now. Same way it has 5. Tree also has the same life cycle now. So Java is picking the concepts from real life. Understood? That is why it's very successful language. You have any questions here? You can ask. I'll type and show you all this. So in methods you only use the resource. You don't close the resource. Following now? In methods you should only use the object level resource. And finalize is a standard method for releasing your resource. Don't try to release your resource by writing in some other methods, because JVM will not call it. It becomes your headache to call the method. Like how you are calling M1, M2, is JVM calling M1, M2 method? It will never call, you have to call it. So finalize is the only method which will be looked by the garbage collector. Okay, so having this in mind now, let's write on simple class now. Yes, now why do you use a constructor now? See, I'm giving you the idea of how to write a class. How to write a why do you, generally your instance variables will be what? Very powerful resources like file input stream. Powerful resources. These are called as object level resources. File input stream, FIS. FIS is a variable of type file input stream. Like that it was. We'll be seeing it later, don't worry. They are built-in classes. I keep telling you now. It's a built-in class. Okay. Library we tell now. It's that. So same way, connection. See, this will get the connection to what? File. It gets you file connection. And this will give you database connection. So your instance variable will be so powerful. Anyway, I'm not going to get file connection, database connection right now because we don't know what is database also. We don't know how to work with files also. So you'll be seeing it later. But I'm giving you the idea of how do you write a class. Understood? So how you write a class, that way your object is going to behave. I'm telling you now, class is the template for what? Object. So we have to study both parallelly. So we are still learning how to write classes only. Logics we'll be seeing later. I'm not teaching you how to write logics. If at all you want to write logics, all this should be very clear. Because without knowing all this, if I start writing the code, no, definitely you'll ask me questions. Why did I write that code in constructor? Why did I write this code in method? Why did I write this code in finalize? All this code I could have written in only one place. We'll have questions. So to answer that question now it will be very difficult. So that's why I'm not focusing on what? Logics. I'm just giving you the idea of or the skeleton of how do you write a good class. Are you following now? Once you know how to write a good class, writing logic is cakewalk. I'm telling you. Do not bother about writing logics. They're very, very easy. So learn how to design your class well. You are or throughout your life you're neglected how to write a class. That is the reason you're finding it very difficult to understand the subject. But it's a very simple subject. How do you write a class? Hardly it will have what now? Instance variables, constructors, methods, finalize. What more is there now? Clear? So now what we do in the constructor, we initialize what? Object level resource. It can be anything. I'm not telling use both. Just I'm telling you these are examples. These are examples. Use initialize object level resource. Example, what are they? It can be a DB connection or it can be a file connection. Just I'm giving you the idea of writing a class C now. So here what will I do? I'll not do all this. I'll simply put on SOP. SOP inside constructor. And I'll show you now the constructor gets executed only once. That is why I'm doing initialization in constructor. See, one is the explanation, how you write a class. Second one, to make you understand the flow, I'm putting SOPs. So right now, for giving demo on this subject, I'll use only SOP. I'll use only SOP. So you can see how many times the print gets executed. If I create one object now, hello, h1 is equal to new hello, in that object, constructor will execute only once. So that is why I take that advantage now. Taking advantage means what? Benefit. Since constructor is executed only once during the creation of object, we use that for initialization purpose. Are you clear with this? Okay, next, M1 method. I'm not writing return type, parameter and all that, don't worry. But why it is a method used? Method will be used for what? Initialize method level resource. Now, what example for method level resource? What can it be? Same database connection only I'll give now. If the connection is required in only one method, what happens now? It becomes method level. If it is required in all the methods, then it will become object level. Means it's a local variable. Are you understanding? Here it's an instance variable. Here it will become what? Local variable. That's all difference. So that's how you write local variables and instance variables. Instance variables are used when you want to use that variable in all the methods. Local variable scope is very much limited now. So I'll go for local variable. So example is here. I can use the same file input stream now or database connection. Okay. But this is instance variable. This will be local variable. So here example DB connection or file connection, anything, or even socket connection, socket. There also socket connection can be made as what? Object level resource. Okay, so then example, okay, like this, what will you do is you'll make file input stream FIS, or you'll have connection con. So you are declaring where now? You'll not declare here now. If you want method level resource, you'll not declare here. You'll declare it locally. Are you understanding now? You write the class. You'll not write this time now. Okay, so what you want object level, there, instance variable, what you want local variables. Okay, so anyway, see, initialize method level resource, and second what you'll do, you'll use both object and method level. You can use both now. You can use, I'm not saying use mandatorily both, you can use both. You have got two resources here now. You can use it. Then finally, okay, I'll put on SOP here. See, the star indicates SOP. SOP inside M1 method. So when I call M1 method will execute how many times? N number of times. Okay, now I'll write M2 also. M2, what it will do now? It will use only object level resource. Fine, not an issue. It's not that all methods should have local resource. It depends on your logic. And depending on your logic, you'll write the code now. But see, have I closed anywhere? Okay, initialize object level, use both. One more thing here, sorry. Close method level resource. This I didn't write. Close method level. See, I did not close object level resource anywhere. Did I close object level? Initialize object level resource has been done. I have not still closed. So here also I am using only what? Object level resource. SOP inside M2. M3 method I can write. I can use only what? Here also I will write. Use. See here you can use only method level resource. I will not use what? Object only. Possible. In M3 method what will I do? I will initialize method level resource and I will use method level resource. I will not even use object level resource here. Possible. So like this we have to write the code. So I will use here. Initialize method level resource. And I will use method level resource. And I will close method level resource. Valid? No, I am not at all using what here? Object level. I am not using only. Fine. But why did I make that as an object level resource? Because it was required in two methods. Understood? If you require it in two or more methods, make it as object level. Single method, method level resource. Done? Okay. M4, you can use again object level resource. Like that you can go on writing any number of methods. But finally, see, to release object level resource, you have to write on method now. It will be within the class. Since I am not having space, I am writing it here. But this code will be where now? Inside the class. So finalize is also one more member of the class now. What we are adding. Finalize is also one more member of the class. So carefully see now how we write. I'll write public. You have to write public only. What is public? Don't worry, I'll be explaining it later. Public void. Void is the return type. Finalize is the name of the method. No parameter. Strictly you have to write like this only. Understood? No parameter. You should not write any parameter. So here we write what? Close object level resources. And if you don't close your object level resource, what will happen? It is eligible for garbage collection. So I'll put on SOP. SOP inside finalize. Clear with the class now? So like this you go on writing variables, constructors, methods, and finally finalize you'll write. So here we write, see here we write initialization code. Remember this, do not forget. Initialization code is nothing but what? Initializing object level resources. Here we write what? Finalization code. Finalization code is nothing but what? Releasing resources. Remember this, do not forget this. Okay, so as and when I write big classes, you should have the clear idea now. What I am doing where. Simply I start writing class now. Okay, that time you should understand, okay, why I have written that code in method. We split the code. It's not that simply writing code. Okay, we have to split the code logically. What code in constructor, what code in method, what code in finalize. Logically we have to split. So once your class is ready, next let's see how you use this now. Class demo published. I will be writing only SOPs. You see the flow in this example. I'll write only SOP. Okay. When I code it, I'll be writing only SOP. So what will I do now? Hello H, H1, H2, H3, or 1 second. I'll declare variables. Hello H is equal to null. Hello H1 is equal to null. Hello H2 is equal to null. Hello H3, or I'll start rename it from H1 only. This is H1, H2, H3, H4. So there are 4 variables, H1, H2, H3, H4. Okay, I'll create up one more. H5 is equal to null. So now, are there any objects? No, till now there are no objects. But now if I want, I can create objects. How will I create? New hello. Yes, this is valid code. Remember this. This is valid code. But the address of that object is not stored in any variable now. So this is still dereferenced. This is a dereferenced object. This is one more example for how a dereferenced object gets created. So that is why what we do, new, we allocate memory. After the constructor completes execution, the address of that, we store it into H1. This is mandatory. If you don't accept that address in a variable, it is a dereferenced object. But if you don't write this, this is valid code, you will not get any error. But it will only create what? Dereferenced object. It will only create a dereferenced object. But there is no use of that object now. So that is why we always write H1 is equal to new hello. Are you understanding how important this line is becoming now? Still more to go with this line. 2 more days, 3 more days, you will understand very clearly what happens in this line. There are plenty of things which happen in this line. So now what happens? See, one object gets created. H1, address is 150. This is H1, address is 150. So what all it will have? Constructor. Have the constructor. It can have this file input stream, or it can have connection. Means it can get the connection to file, or it can get the connection to database. That depends. It will get it now. As soon as the object is created, it is ready, initialized. You can only use the object now. So that is what you mean by initializing an object. As soon as the object is ready, object should be ready for what? Usage. Till now what we are doing, we are creating an object and initializing WHND. Yes, that is also initialization only. But initialization will be so powerful. Technically, when we use it in programs. Are you clear with this? So it can be, you can have a connection to file, or you can have a connection to a database. That's up to your wish. A file or a database. Leave it. So constructor is there. Then you'll have M1. Then you'll have M2. Then you'll have M3. Similarly, you'll have finalize. So all the members will be there now. This is H1 object. Similarly, I'll say H2 is equal to new hello. So how many objects you create? Go and see the output. That many time inside constructor will execute. Understood? So again one more object will get created. Again it will also have what? H2. It will also, a file input stream will be there. One more connection is there. So this will be file, this will be connection to database. You will have one constructor. You will have same, what is there in your class, same thing will come into existence, and you will have the finalize method. Same. Again you can have one more object, H3. Same things will be there. I can have H4. Running short of space, 1 second. What is correct? 1 second, I'll write it this side, that's it. H3, H4. So we have 5 variables. Similarly, you can create one more object, h5. So this address is 150, this is 250, this is 350, this is 450, this is 550. You can check. So like this, you can create 5 objects. How will you create? h1 is equal to new hello, h2 is equal to new hello, h3 is equal to new hello. So you are only instantiating. So all the objects will get created now, and all the 5 variables will be referring to 5 different objects. Are you clear with this? So inside constructor, inside 5 times you will see. Now once the objects are ready, I can call the method in any object. That is my wish. Like I'll say h1.m1. So method will be called. I can say h1.m1 again it will execute. Or if I want the method to be executed in h2, h2.m1, it will execute in h2 now. If I want in h3.m1, it will execute, no issues. So I can call the method in any object. And all the objects are referenced objects. There are no dereferenced objects right now. And if you want, we can call something called as, write the code, system.gc. This is one way you can call the garbage collector. So system is on built-in class. System is on built-in class. No library now. We are using a system.out.println. Same class you use, system.gc. GC is a method inside that class. We'll be seeing this in detail later. But just understand, GC is a method present in class system. If you call this, garbage collector will come now. It will come, but it does not find any dereferenced object. So it will not collect any. So you will not see the output of inside finalize. So till now what output you have seen? Inside constructor 5 times. Methods depends how many times you are calling. So the number of time method gets executed depends on the amount of time you are calling the method. Understood? Constructor depends on the number of objects you have created. Methods will depend on how many times you are calling the method. But finalize will not execute because there are no dereferenced objects. Understood? Now what you do, you can dereference. See this, h1 is equal to null. So h1 will refer to what now? Null value. So this is dereferenced. I can go on dereferencing. There are many ways you can dereference. Okay. Now see, h2 is equal to h3. Now the value of h3 is given to what? h2, and h2 will refer to this. This is dereferenced. Understood? Next I can say h5 is equal to new hello. Again I am saying new. So h5 will now refer to what? One more new object which will have hello, m1, m2, but it will dereference this object. So like that, you can give an allocate new memory and give it to that variable. So now 6 objects are there. Earlier there were 5 objects, 5 variables. But now since you told new hello, one more object is created and given to h5. Now I say system.gc. Now you say, this time garbage collector will come. How many dereferenced objects are there? 1, 2, 3. 3 dereferenced objects are there. It will reclaim that memory. See, till right now we are calling the garbage collector. Actually there is no necessity for us to call the garbage collector also. JVM is quite intelligent enough to identify when there are too many dereferenced objects. If you want you call, if you don't call also, still it will come. Now why did I call here? Because in our program there are hardly 3 objects. For 3 objects and all, no, for the garbage collector no need to come. Okay, garbage collector generally comes when there are too many dereferenced objects. Understood? So that is why I am calling it explicitly. So I am calling the garbage collector, it will come now. Once it comes, what it will do? These 3 objects it has identified. It will collect. But before collecting, what it will do? It will call finalize. It will call finalize, and you can see the output 3 times. Inside finalize, inside finalize, inside finalize. But actually how many objects got created? 6. But finalize, how many got executed? Only 3. Only 3, because there are only 3 dereferenced objects. Are you clear with this life cycle now? Dereferenced objects only 3 are there. But constructor how many got executed? 6 got executed. So this is how they have designed constructor and finalization. Are you clear with this? So I'll put it into coding and show you now. But I'll only write SOP everywhere. Are you clear with this? Do you have any questions?
Yes, sir. In that M1 method, is it mandatory to close method level resources?
Yes, you have to close method level resource, because what happens, in M1 method, his question is, should I close the method level resource? Any resource you open, you should close. First thing is that. Okay, any resource you open, you should close. If you don't close the method level resource, again when you call the method, again one more connection you will get. Understood? Local variables will come into existence whenever the method is invoked. So every time you call the method, it will come into existence, it will get initialized. Previous connection you are not closed. So it's always ideal to close all the resources. But when will you close the resource is the question. Local resource locally, object level resource in finalize method.
No sir, anyhow the scope will be for that M1 method.
No, we cannot depend on scope. We have to manage the resources. His question is, anyway the scope of variable is local. Variable will be destroyed, but who will close the resource? Resource will be open only. Understood? So we have to close the resources. Simply destroying the variable is not the solution here. We have to actually release all the resources. So remember these two things. Management is of two types. One is memory management, other one is resource management. In Java we do not bother about memory management. We only bother about resource management. Memory will be reclaimed automatically. Here I am calling system.gc. Later on you will not do this also. GC is one method in the class called as system. Yeah? Any questions you are having? So we are seeing what now? Life cycle of object. In C++ also same story is there. But there they call it as destructor and all that. That is more complicated. And there even if your object goes out of scope, it will be destroyed. Big headache is there. You should know how to handle it very carefully there. Okay. But here, as long as your variable is, object is referenced, it is never eligible for garbage collection. I'll be showing you that also. Clear? Okay, I'll talk about it. And now see, supposingly, now see this. In this example, if I call finalize, what will happen? See, I created 5 objects. Here, I'm calling M1, M1, M1. Supposingly, if I call h1.m1, what will happen? Finalize method will execute. I'll see the output also inside finalize. But after that, still I can continue calling what? h1.m1, I can call it. Why? Because object has not got dereferenced. After calling h1.m1, see, after calling h1.finalize, say I'll call h1.finalize. After calling this, again I can call h1.m1. No issue, it will work. But here, only print, now it will print. But supposingly resource was there, we would have unable to use it. But this clearly shows that calling finalize on an object will not destroy the object. It is still under reference. And I can call other methods. But if you call other methods, if that method was using a resource, it would have been unable to use. If you had, supposing if you call finalize, what will happen now? Only resource will be released. And after releasing the resource, if I call M1, M1 cannot use the resource. That is the problem in actual scenario. But here it will execute, it will print what? Inside M1. Because hardly we have put what? SOP. It will print. So what does it clearly show? Calling finalize explicitly will not destroy the object, or it will not dereference the object. Calling finalize explicitly will not dereference or destroy the object. It will only release the resource. So this is one important question which we get. Can we call finalize explicitly? Yes, we can call finalize explicitly. But calling finalize explicitly will never destroy the object, but will only release the resource. It will not. The only way in Java you can destroy an object is to abandon it or dereference it. That's the only way. You cannot destroy the memory in Java. Is it getting clearer? You cannot destroy the memory in Java at any cost. Okay, destroying memory will be taken care by garbage collector itself. You can only stimulate the process by dereferencing it. More than that you can't do anything here. But allocating memory, yes, it is in your hands. Developer has to allocate memory. See, new, he has to go on allocating the memory now. Are you clear with this? Yes, still you have any questions, ask. Else I'll type and show you this output. This is life cycle of an object. I'm still continuing to teach you how to write a class. Understood? And the class is a very rich data type now. You can see how powerful your data type is. It's so powerful, once you write your class, you can use it in any operating system of the world. This data type, you cannot find it in other languages. So powerful data type it is. That's the reason Java is having so much of success. The reason why Java is so successful is what you code you write once, it will run in any operating system of the world. Should I clear all this now? You have any questions, ask. Clear? See, management. Developer has to manage two things. One is memory, other one is resource. You take care of this. Memory implicitly by JVM. This developer. Local or object level, you have to manage it. Developer has to manage resource. Remember that. Any resource you open, close it. This memory, no need. Developer. Clear? Final summary of what I told you till now. Clear? In memory, who will do this implicitly by JVM with the help of garbage collector. Here we will do it with the help of finalize method. Now more questions will come. Can I overload finalize method? You can overload, but garbage collector, it will not give you compilation error. You can overload any method, but garbage collector will look for this signature only without any parameter. Supposingly in on class A, I will show you that also after coding. Supposingly I have two finalize methods. One was your normal finalize. Now when garbage collector comes, which finalize will it call? First one or second one? First one. By chance if I don't write first one, which one will it call? It will not call only. It will not call because it's not finding it. So garbage collector is always going to call one without parameter. This is the same signature it looks. And SC also you don't use. Finalize, ZD I am using now. You change the spelling name, it is treated as a different method now. So overloading of finalize is possible, but garbage collector looks for finalize without any parameter. Understood? Now coming to the discussion of constructor and okay, first I will type and show you this, then we will continue the topic. It is dead opposite of constructor, ma'am, that's it. It is dead opposite of constructor. See, this program you have to focus only on life cycle of object, how constructor we are using, how methods we are using, how finalize we are using. Only focus on that. Don't bother about which one, garbage collector and all that. That story is different. I'll be telling you that story later. Concentrate only on life cycle of object. Class life cycle of you can give a folder name life cycle. See, I'll just go on putting SOPs, more than that I'll not put anything. I'll write M1 and I'll write inside M1 method. inside M2, inside M3 method. So, and we have to change these names. This is M2 and this is M3. Okay, we have to give return type. Are you clear this? So now you have, if you want, you can write finalize, else you can leave it. Understood? Like how it is optional to write a constructor, similarly it is optional to write finalize. When do you write a constructor? When you want to do initialization. Similarly, when will you write finalize? When you want to de-initialize or finalization process. Understood? It's optional. So now, but I'll write it. But the signature of this one looks like this: public void finalize. Yes. Now you can write inside finalize, some stars I'll put so that we can see it, the output very clearly there. Anyway, this is just your output. You can put anything like this, so it will be identified. Okay, now see this. Hello H1 is equal to null. Now you can write H2 is equal to null, H3 is equal to null, H4 is equal to null. And I'll call system, like this only you type, observe how the things get executed. System.gc, I'll write here inside begin of main, and here we'll write end of main. So in between begin and end of main, we'll see what happens. Done. So we'll compile. Control 1 compiles and we'll execute. I have not created one object also. So no constructor also, no finalize also. Just I have declared the variables. See the output? Begin main, end main. Nothing happened. So now we can start creating the objects. H1 is equal to, do not type the program in one shot and see the output. Step by step you have to go like this. See, I'll create two objects, and if you want I can print the address, it will be different. So again I'll create the objects and two objects, but there are how many variables? 4. So you can see inside constructor is executed twice because I created two objects. Life cycle of every object now. Every object will have its life cycle. So this is also having its life cycle, that's also having its life cycle. Next, if I want I can create more objects, but GC did not execute now. Inside finalize, did you see the output? No. So now see H3, H4. So how many objects I have created? 4. So you can see now. Inside constructor is executed how many times? 4 times. Okay. So again I am calling system.gc. Nothing is happening here. Okay. Now I'll call methods. Which object you want to call the method? You call h1.m1, h2.m1. So methods are used for doing service. How many times you want you do the service? h1.m1 only I'll call. Okay. Again I'll call h2.m1. Means you can call the method in any object any number of times. So methods are used purely for doing service. So what you want to execute n number of times, that logic you write in methods. What do you have to execute only once during the creation of object, that you write it in constructor. What you want to execute only once during the destruction of object, that you write in finalize. Very simply classified here. So neat. Okay, very user friendly. Are you clear? So still methods execute m1, m1, m1. It might be from h1 object or it can be from h2 object. That's secondary. But still finalize has not got executed. Are you clear with this? Okay, one more object I'll create now. Which one? H5. Now how many constructors, sir? H5. I have not declared. Okay. How many times constructor? 1, 2, 3, 4, 5 methods, it's up to you. But still garbage collector has not executed anything. But now I start dereferencing. Clear? Say I'll dereference. H1 is equal to null. Isn't it dereferenced now? If you want, you can see the address. Earlier H1 will print some address, but now it will not print any address. Now I'll say H2 is equal to H3. Now what happens? The address of H3, value of H3 is given to what? H2 now. So H2 will refer to which object now? H3 object. H2 will now refer to H3. So that object becomes dereferenced. Then I'll say H5 is equal to, okay, first we'll see this. So now how many dereferenced objects are there? 2. Now I'll call the garbage collector here. Okay, I can cut it and see, I'll do one thing. After creation of objects, I'll call finalize. Sorry, I'll call garbage collector after creation of object. After execution of methods also, you can, I'm not calling it, I'll call it here now. Straight away where I'll call? I've used the object, now I've dereferenced and now I'm calling. So here also on GC is there. Here also on GC is there. Carefully notice. Both the times garbage collector will come. But here it will not execute finalize. All the methods will execute. Inside M1 will execute. But here what happens? Finalize will execute. How many finalize? 2. So here you can see now, I created 5 objects. 5 objects, H1, H2, H3, H4. So 5 objects got created. Then methods, see system.gc, but no output here in this line. So M1 method is getting executed. Then I will dereference. Then I will call system.gc. Now it has come. Did I call finalize? Who is calling finalize? JVM will automatically call it, or garbage collector only will, JVM will send the garbage collector. Garbage collector will call the finalize method. JVM will send. Okay, but send the garbage collector. Garbage collector will invoke the finalize. Did I call it? No. So we are taking advantage of this. Since the finalize is executed only on dereferenced objects. So what we do? We do the finalization process there. Done? So then this is done. So system.gc, end of main. Okay, if I want, I can dereference like this also. That's up to you now. H5 is equal to new hello. Now again one more constructor gets executed, and then what happens? Plus constructor also executes. So 3 finalize now. See now the constructor where it is getting executed. See here 5 constructors M1. Then again after M1 we have dereferenced, and 3 dereferenced we are creating. Null H2 is equal to H3. But I have created an object. You can see that execution here inside constructor. Then okay, anyway, end of main has printed earlier itself, no problem. But that's only output. But you can see 3 finalized output statements have been executed because they are right now 3 dereferenced objects. Are you clear with this? So now we'll remove this. Is it okay now? Okay. Now next. See, after calling h1.m1 all this, I will not dereference any object. I will explicitly call what? Finalize. I will call developer. I means developer. I will call the finalize. h1.finalize, h2.finalize. So calling finalize will not calling finalize explicitly will only see h1.m1. I can call the method again. h2.m1. Calling finalize explicitly will not destroy the object. See, here also we are calling system.gc. Here also we are calling, or I will not call only, better. Here also I will not call. Here also I will not call. We are calling. Which one? Finalize. So now see what happens. But after calling finalize also, see, we are calling, invoking it. Still I am able to call which one? M1 method now. So calling finalize explicitly will not destroy the object. we'll only close the resources. If I had any resource in finalize now, it would have been closed. After closing that resource, can I use the method now? After closing, I can call the method, but that method will be unable to use the resource. So that time we say it's a useless object. It's a waste object. Your object is referenced, but it is a useless object. It is not fit for anything now. Are you clear with this? So here it will print why only SOP is there. But supposedly database connection was there. What would have M1 done now? If you had closed the database connection, what would M1 do now? You cannot use the database connection. Understood now? If you call finalize and close off the connection, what will M1 and M2 do now? M1 method do now? It cannot use the connection. So that is why we should not call finalize. Understood? We should never call it. It will be called implicitly only. Are you clear with this? Okay. Now some document we'll see. 1 second. So are you clear with all this? I'll come back to the document. Do you have any questions? Do you have any questions now? You know how to use the finalize method now? Okay, sorry. I didn't show you overloading of which one? What happens if I overload the finalize method? Okay, overloading finalize method, no use. The garbage collector will look for finalize with this parameter itself. Okay, 1 second. So let me type and show it to you now. Do you have any questions now? I'll show you all the other things now what you might do. One second, projector let it switch off. So in every class now what we do is we might have a finalize method from now on. We might have. So be careful when I use the finalize method. 1 second, I think it's not switching on. Now it's okay. See, I have written one more method here, which is overloaded. We know overloading now. Overloading is nothing but what? Same method name with different parameter list. So this has been overloaded now. Say I'm having one int. You can send any parameter, int, double, that's your wish, but it's overloaded. So now if I call C, I'll destroy the objects. And you can see the print statement here. What I have done? Inside finalize method with int star star star. One is with plus, one is with star. You can see always finalize with plus gets executed, not with star. So I'll dereference. You know how to dereference now? H1 is equal to null. H2 is equal to null. Like this you can dereference and say system dot gc. Now see, two finalize will be executed. Null pointer exception. Okay, I means I'm calling, sorry, after calling h2 is equal to null, I'm saying h2.m1. Sorry for that. Means after you say null, don't try to call the methods now. Okay, I'm dereferencing and now what will I do? See, finalize, which one? Plus is getting executed, not with star. That will be treated as a normal method now. Finalize, overloaded finalize will be treated as a normal method. And don't overload it. People will get confused. The user of your class will get confused. Okay. So now, okay, what happens if I don't write this method now? That's also a question. Finalize will never be called. See there. It is not there, it will not execute. Yes or no? If it is not there, it will not execute. So compulsory you have to have this particular finalize one. Are you clear? We can overload, but we should not do it. Understood? You know why overloading is done now? When functionality is same, that is when you have to overload. Okay, here you will not get that scenario only, so do not overload finalize, and even garbage collector will not call finalize with the parameter list. It will always call with this signature only. And what happens if there is a spelling mistake? Yes, see, no, it will not call this also. See, again we are dereferencing. I will call, it will not execute anything because the method name is SC. Compulsory your method name should be ZE. So this is all very strict. So you have to write it in this. Now what is the benefit of all this, you know, no? Supposingly I write on class, one good class I will write which will use the database connection and all that. I will write the code. So all you will do is what now? You will create an object and call the method. That's it. You will not bother about the resource management and all that, no? Imagine how beneficial it is. If one person struggles to write on class here, how many people can use on class so efficiently here? That is the level of reusability we are talking, as well as resource management. So when I write a class, when the others will use my class, they will go through my members. They will study how many constructors I am having, how many methods I am having, do I have a finalize, all that he will study. If there is anything in finalize method, he will not bother to see it only. He will come to know that it is resource release code. If I written any code in constructor, what will he think? Okay, it is resource initialization code. Very clearly you will understand now. So if one person takes pain and writes the class here, thousands of developers can use your class so neatly and cleanly, efficiently you can use. If anything is there in the method, okay, he'll understand what is there in the method. So after he studies the class, next he'll not bother to look into it. Simply what will he do? He'll say hello h is equal to new hello, he'll create the object h.m1, h.m2, he'll call the methods. That's it. He will not even bother how he is getting the output also. And that is itself called as abstraction. Understood? How the resource is managed, how the resource is getting opened, how it is getting closed, he doesn't have any idea. Fine, but he is getting the output. That is itself called as abstraction. Such an elegant approach for what? Abstraction. Once the object is created, you can use it. So, for implementing encapsulation, abstraction and all that, we are using which data type now? Class data type. So what is class now? Class is a user defined data type which can be used for implementing OOPs. That's how we start defining a class now. More technically, class is a user defined data type, everybody knows. Class is a template, everybody knows. But class is a user defined data type which is used for implementing OOPs is more technical now. Are you getting clearer? Still you will see what a class is. More and more clearly we will start seeing what a class is. Understood? It's one of the most brilliant data type what Java has given to you. Clear? Do you have any questions related to this now? Do you want me to type anything, change code here, show you? If I do like that, what will happen? If I do like this, what will happen? You have any questions, sir? So we will fill code here. Remember that. We are going to fill code in constructor, M1, M2, M3, finalize, I will fill code. What? Logics. That time you will clearly understand. The flow if you understand now, there you will start clearly understanding the execution. Clear? Any questions? So we have covered what now? Life cycle of object. We have covered life cycle of object. Clear this? Okay, now before we proceed, we'll see this one now. See, you know why you use a constructor now? Initialization purpose. Okay, fine. See, one more thing what you have to understand now is, later on you will be seeing all this. Later we will be seeing this. So there are so many built-in classes. I have told you about like how we give the name to the classes. We always first letter of the class name will be caps. If the class is having two words, second word first letter will be caps. You know that convention, camel casing. Okay. Similarly, there are built-in classes. There are built-in classes in Java. Okay. Some of the class names are system which we are using, which you have heard. So there is a class called as system. Remember that. Similarly, there is a class called as string. Similarly, there is a class called as string buffer. These are all built-in classes. Remember that. Understood? Similarly, there is a class called as class. The name of the class is itself class. It is a built-in class. Understood? Similarly, there is one more class called as object. You don't have to worry too much about all this. They are only names. Like how you write class box, class hello, they are also name of the classes. Okay. So now see, these are classes, finally in that class what will you have? Members now. End of the day what will you have? It's name of the class, but finally you will be having what? Members. Okay. This point you will be seeing later, very in depth I will be taking later for you. In the class called as object, clear? In the class called as object, there are some members. Okay. There are so many members. There are around 10 to 11 methods are there. One of the method present in class object is called as protected void finalize. There are many other members. We will be seeing it later. One of the member present in which class? I am not talking about these classes now. Leave it. You are only seeing class object. One of the member present in class object is finalize. Understood? So this point we'll be seeing later. Now initially this part what I am telling you now 2-3 minutes you will not understand anything. Slowly you'll understand later. Okay, slowly you'll understand later. Any class in Java is a subclass of class object. That you understand. We are not seen inheritance still. When I go to inheritance I'll teach you all that. Any class in Java is a subclass of class object. By default it is. If I write class box will be extending object. If I write class hello will be implicitly extending object. There is something called as inheritance which we have to see later. I will be covering it. Okay. So what happens? See, now we have written class hello. I didn't write the word extends object, but by default it will be extending what? Extends object. Remember this. Okay. And here in hello class you can have constructor. Yes. You can have M1 method. You can have M2 method. All that story is there. But if you are interested, you can write finalize method also now. If you are interested, you can write this now. Okay, when will you write constructor? If you want to do initialization. When will you write finalize? If you want to release some resources. Okay, what is constructor? Constructor is a special method which has the same name as class name. What is finalize now? It's a method, predefined method present in class object, and we override it in subclasses. We do overriding. Till now I not taught you overriding. So this part what I explained to you now you will not understand. Simply document it. Okay, clear explanation for this I will be giving you later. Understood? Just understand the usage of finalize. From where it comes, what it is, what is overriding, I will tell you later. Understood? So finalize is a predefined method present in class object. It is overridden in subclasses to release object level resources. This is what you have to tell in interview. Understood? It's technically derived like, means we have to tell like that. What is finalize? You will tell it's used for releasing resources. But more than that you have to add these points. What? Finalize is a predefined method. Predefined method means an already existing method which is present in class object. It is generally overridden in subclasses because all class in Java is subclass of what? Object. So it is generally overridden in subclasses to release object level resources. Now if you question me what is overriding in one sentence, I will tell you, not more. The signature is same. Overloading means what? Parameter will vary. But here what will happen? It will be ditto to ditto same. So having two methods with the same signature is called as overriding. And overriding is not that possible in the same class. It is always possible in subclasses, different class. So this I will talk later. Understood? This topic I will be covering later. You don't have to bother about this 5 minutes explanation what I gave you. You don't bother. We will be covering because there I have to cover inheritance. Then I have to explain you overriding. There you will understand that subject. Clear this? So these 2 points you have to tell now. Okay, so when you write the notes also you have to write properly. Finalize is a predefined method present in class object means how will you write? Finalize is a predefined method. So you have to write like this. See? Finalize. You have to put brace. You will understand what it is. Because what is keyword, what is method you should understand. Finalize brace you put. Whenever you talk about methods put brace. is a predefined method, okay, present in C, this time C small. Understood? Because I am talking about a keyword, O caps. I am talking about the class, built-in class. Following now? This is how you have to write. Now one more, some other time I'll tell. I am creating an object of class object. That time how will you write? I am creating an object. Object means which object now? Our normal object. Bringing code into existence. I am creating an object of class object, O caps. You should know how to write. I am creating an object of class. I am creating an object of class. See now? Because this is also built-in class. You should know how to write the notes. So this time if I write capital O, what will happen? You will get confused. So you should know when to use capital O, when to use small o. When I talk about the class object, write O caps. When I talk about our normal object, write O small. Are you clear with this? So write your notes properly, otherwise you will not understand your own notes tomorrow. Understood? So this is how you write. Finalize is a predefined method present in class object. Are you clear with this now? Yes or no? Clear? Is it visible? I'll clear anyway. See, this is how you write. Finalize is a predefined method present in class object, O caps. This time O compulsory caps. Because we are talking about what? Class. I am creating an object. Means which object you are talking about? The normal code coming into that you are talking, that time O will be small. Okay, of class. Again it's a keyword. Here it is keyword. Here it is class name. Similarly, I am creating an object of class. Here also it is keyword. This class is built-in class. So write your notes properly, then you can understand, because we will be discussing about all the built-in classes very shortly. So if your notes is not correct, I am creating an object of class. If I write everything in small, I am creating an object of class. What will you understand now? God only should save you. Understood? Either one C, this C also caps, no problem. But one C caps, one C small. Here you are telling this is the class, this is the keyword. Class. No problem. Understood? So more than following the English conventions of writing notes here, follow Java conventions of writing notes. Don't use your English conventions. Supposingly finalize is at the beginning of the statement. Still write F small only. Understood? Finalize is the beginning statement. Now I'll tell finalize is a predefined method. What will you do now? First line now, first letter, you start following English. Finalize, full stylishly you'll write. You will not understand what it is. This is how you write notes. Finalize is predefined. How will you understand tomorrow? Are you following? No, do not write notes like this. Always when I say finalize method, immediately, even if it is in the first line, first word of the first sentence, English, okay, you should write it as like this only. See here how I have written. Are you clear? Okay, fine now. So what is finalize now? Finalize is a, so you have to write the points like this. Finalize is a predefined method present in class object. It is generally overridden in subclasses to release object level resources. You have to write the statements very clearly like this. Are you clear? Okay. Then after this, I think that's it about finalize. We can overload, but we should not overload. Okay, and we can call finalize explicitly, but we should not call it explicitly. Okay, because it will only release the resource and makes the object useless. And we'll compare the constructor and finalize now, because they are dead against. Okay, so we'll see what is the difference between a constructor and finalize now. Okay, with that you'll understand how to use the constructor and how to use finalize now. Are you clear with this? Do you have any questions? Do you have any questions till now? So I'll show you the document now. With that, this finalized topic comes to an end. So you should know how to use your constructor and how to use finalized method now. See, the subject becomes more and more clearer as we progress ahead. Okay, so once your object is not a simple topic as you're thinking, it's a very vast concept and it's a very big topic. Gradually every day we are seeing what an object is. But finally you know what is an object now? Do not forget that. It has life cycle. But object is nothing but code coming into existence. And object is containing what? Complexity. To work with the complexity we need the reference variable. Okay, without the reference variable you can't work with the complexity of the object. Can you work with the complexity of anything without the handle? No, same here. Can you work with the complexity of the engine without the gear? Can you work with the complexity of the watch without the key? Can you work with the complexity of the TV without the remote? No. So to work with the complexity you need the handle. Same way here, to work with the complexity of the object, okay, we need the handle. The handle is itself the reference variable. They all continue. I'm not saying no. Apart from that we are seeing more things now. Okay, and always object contains complexity. You call the method that complexity executes. Understood? But for creating an object you should know how to design a class. That is what we are discussing. You know what an object is. So are you clear with this? So let's finish it off now. What is a constructor? See the difference. I'm comparing now. It's a special method which has the same name of the class. But what is finalize? It's a predefined method in Java which is present in class object. Clear? Differences. Next. It is used for initializing object level resources, or we can sometimes say state of an object, or sometimes we say initialization process. But what is this used for doing? It is generally overridden in subclasses for finalization process. Or we can also say it is used for releasing object level resources before an object gets destroyed. Now the main point, it is executed only once during creation of every new object. Every new object it will execute. But this one, it is also executed only once, but during the destruction of only dereferenced objects. That this one only. That's why I underlined. Every new object, this is only dereferenced object. Then next, constructor is invoked explicitly by developer whenever he wants to create new objects. It will be implicit, see here it will be implicitly invoked by JVM before the garbage collector destroys the dereferenced or unused object. It will be invoked implicitly. Next, constructor can be overloaded. Finalize cannot be overloaded. We write like this difference, but technically you know no. You can overload the finalize, but you should not do it. Okay. But here while differencing we write like this. Constructor can be overloaded, finalize cannot be overloaded because it will not have the functionality. We will lose the functionality now if you lose the overload which one? Finalize, we lose the functionality. So this is the difference between a constructor and finalize. Are you clear? These are very important points. You can write it. Okay. Then finally, calling finalize explicitly will never destroy the object. Yes or no? Calling finalize explicitly will never destroy the object, but it will only release the resources used by the object and makes the object useless. The only way we can destroy an object in Java is by dereferencing or abandoning the object. Yeah, if you want to destroy an object, dereference it or abandon the object. That's it. Means h1 is equal to null, h2 is equal to h3. Abandon it. Okay, that's abandoning or dereferencing. Both mean same. Do you have any questions now? Is the topic clear? Is the topic clear? Any questions you are having? No? Okay, see in interview they'll ask you difference between three things. One is final. Finally. And the last one is finalize. I only covered finalize now. These three differences is definitely asked in the interview. What is the difference between final, finally and finalize? Understood? We have covered only finalize. Finalize is a predefined method present in class object. So we'll see these two later. So this is method, remember that. This is predefined method. Okay, but these two are keywords. We'll be seeing it very shortly. That's the first difference. You have to start from the basic. Understood? Any questions? Shall we close then? Clear now? Okay, that's it then.